Okay, what chapter will be covered in your test 1, which is module 1, module 2, and module 3 only. There is no question coming out from your lab. Okay, no question from lab. Although like some subject will be asking about question exercise from lab, but for OS we did not cover question from your lab, especially for lab 1. Okay, so let's start with our thread chapter 4. And for your information also, I asked you who going to come to the lab, isn't it? But I think none of you are replying, especially on the date and time that you want to come to the lab to use the lab computer. I already create a new submission. Why by default it's 2? I already create a new submission for your lab 1. I already also update the deadline. So please make sure there is no extension anymore, okay? Because we already done our lab 1 is already too long. And there is no extension anymore. It will be on Saturday. Okay, Saturday, not Saturday 1 a.m. It is the midnight on Saturday. So means that Friday midnight you need to submit. There is no more extension. You have another 5 days, 15 hours. So if you have any problem, please inform me by today. Not waiting until the last date of 16 April. Okay, I already give you extension. I hope that whoever want to use the lab, you can go to the School of Computing as soon as possible to finish your lab. And make sure you're going to screenshot using your I think unique name. So if you are using a computer from lab also, please make sure that it is not similar with your friend. Might be one or two will be getting a similar answer for the screenshot, but not all, because there is a lot of PC at the computer School of Computing, and of course you're going to come to school together, right? That's why not going to use one computer only. Okay, so that is on your lab 1. I already upload module 04 and module 05. So now last
Doctor,
yeah.
may I know which question in the lab 1 requires a screenshot as evidence that we did the question, we
Okay.
answered the question?
Part A. Part A last question. Part C last question. Wait. Where is the lab? Alamak, download. This one. Question number 17. For part A. You need to screenshot, and I already asked you, I want to see your unique name compared to your member. I asked you to write your name and then your team member name, so I can see that your answer is different at this side only for you and your team member. So you're going to screenshot your own computer architecture. Supposedly you're going to get your like home slash desktop and so on. So this normally going to be unique because your machine going to have your own name, isn't it? And another one is your part C. Part C also last question. Question number 9. That is only 2 questions require you to screenshot, and it's going to be your own machine's name. Okay. Any other question related to your lab? Okay, we're going to start our trade chapter 4. Okay, please start your your study revision throughout module 1 until module 3 for the test 1. It is not going to be hard. It's just a matter of equation. Let's say okay, like this. Multi-action executing simultaneously. There will be 3, let's say. But there is a question. It give you another one. So you need to pick which one is incorrect, which one is correct. So in that type of question only. But you need to remember everything's in the slide. That's why it's going to be took time for you if you want to refer to notes. It's not going to be happen like that. Okay. Please make sure you read it. Okay. Now, last chance for you. Please scan your QR code because we're going to start our class. After that, I'm not going to share again this QR code. Scan this QR code and then we're going to start our class. For those who coming late or didn't come, I'm not going to share this QR code. How much? 34. Okay. Okay, all of you already scanned the QR code. Going to start. Okay, in trade, we have only 2 overview and multi-core programming. It is not too long. It is like about I think 30 slide only compared to others module like 50. It is quite similar to module 3. It is about 30 slide only, so not too long. It is more on theory as usual, so you can read what is the objective, and you need to make sure that upon finish the module 4 you can understand the notations of trade of fundamentals, which is the fundamentals units of CPU utilization that form the basic multi-thread computer system. Thread, what is the meaning or definitions on thread? There is a lot of definition, but this is the most simple definition for thread, which is a basic unit of CPU utilization. Normally in this one slide, it also hard for me, okay, to create the equation for your test 1, although it is like from 1 until module 3, because might be, I don't know, a different person, but because of, I think it is hard for me to ask a theory question. So in like one slide this, I was like, how to ask a question. Okay, like this might be I can ask about treat. What is incorrect information about treat? So I give this is question number 1, let's say question. A, thread is a basic unit. B, it have a components of program counter, set of register, and stack. C, I just changed thread did not have its own thread ID. I just changed that. And number D might be thread share items with other treats that have created the same process, might be something like that. So this is the incorrect statement. Just that from this slide. Maybe you said, oh, if it's coming directly from the slide, it's easier for you. You just need to find which is the information for the slide. So you need to imagine, okay, let's say the minimum for module slide you have 30 pages, let's say. So module 1, I think 50, module 2 like 50, so altogether you're going to have 130 pages. So one question, let's say you want to find, where is the question, treat at what pages? So although it is just directly from slide, to find out where is the pages, it's going to take minutes. So supposedly one question you're going to spend only like 1 until 2 minutes maximum. So when you need to find out in the slide, and then you need to carefully read back all the statement, it's going to take time. So that's why you cannot finish all the question on time. So please make sure you memorize all the things. Maybe you can have your own keywords, like notes, small note for each slide or for each subtopic. Okay, so we continue. Treat have a several component, which is computer counter, set of register, and stack. And normally it has its own treat ID. So might be you're going to have treat 01, 02. So it's have their own unique ID. It's not going to similar. In one time, it's going to have a several treat ID. And it's going to share with other treat. Let's say you have 01 and 02 treat. Okay, if they are if they are created same process, they're going to share 3 items, which is code section, data section, and operating sessions resources. Have 2 treat. Let's say when you're going to create a same process, maybe you want to create what process, you need to open Microsoft Word, let's say. So it is a program, but when you try to execute it a process. If you still remember your module 3. Okay, so when you try to open, you execute, it's called as a process. And if you try to open and do a same process, you're going to share the same following item, which is code section, data section, and operating section resources. Most modern applications are multi-thread. So mostly nowadays, we didn't find a system anymore like having a single thread. We normally have now is a multi-thread, and it's run within the application. And you can see, let's say, this is example. You want to open your Microsoft window. This is what? Program. Please make sure you can differentiate between program and also process. This one in module 3 is going to be asked in your test 1. And yeah, I think it's going to be also come out differentiation between program and process. So please make sure you understand. Okay, when you have a program, you try to execute. You're going to do a process. So within a process, you can have a multiple thread inside. treat 1, treat 2. So this is example, might be you have another treat 3. So multiple tasks in application can implemented by separate treat. Maybe, okay, maybe you're going to open your window Microsoft Word, right? So one of the treat, what is going to, so this one, the purpose of this treat 1, treat 2, treat 3, as mentioned previously in previous slide, you want to have the same process. You want to open, you want to execute the window, words, Microsoft Word. So you have share several information because you want to open one program only. And when you try to open this, might be there is several functions need to be called. So that's why you're going to separate several tasks just for you to open and to execute one program. Might be one of the treat having a function to update the display of your Microsoft window. And then treat 2 might be it's going to try to fetch the data. Might be you have the history, might be you last time you didn't save carefully, so it's going to be find in the recovery mode and data. So one of the treat is functioning to fetch the data. So might be you going to have also another treat. When you execute the Microsoft Word, there is a checking, spell checking your error of spelling, and it's wrong. And another one, let's say you have another treat number 4. It's going to answer a network request. It depends, because sometimes you can see also in your Microsoft Word, you need a connection to the network just to check whether there is an update for your Microsoft Word. So it is also possible to happen in the treat, but only one process to open one program, but you have a multiple treat inside. You can see. Okay, process creation is heavyweight while threading creation is lightweight. Okay, in this also, in this one sentences, you can be asked with a question. Okay, might be I can ask, which is the statement are correct. So I give you process creation is heavyweight blah 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 for A. B, I just change. Process creation is lightweight while treat creation is heavyweight. So that is option B. C, I give you process and treat is heavyweight. And D, I give process and treat is lightweight. So you can see only one sentences like this, I can ask you a question. So that's why I ask you to carefully remember all the information in the slide, because all question coming out from the slide directly. So it's hard for us to ask you a question. That's why we need to find out which question that, okay, we can play around with. So just a simple like that is going to be asked in your test 1. So I just done it yesterday for multiple choice question. But today I need to create a question for part B. Part B I still don't know how to ask, because mostly it's all theory. It hard for us to ask online question, because everything you can copy paste, you can refer back to the slide. But for face-to-face exam, it's easier for us. We just ask, give the definition or briefly discuss blah 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 on treat. Maybe briefly discuss what is process and what is program. So you need to write in your sentences, but online we cannot ask you like that. Okay, that's why it's hard for us to create a question, especially when we want to embed a question directly from e-learning. Okay, can simplify code, increase efficiency. This is the task and also a function for your thread. When you have a multiple thread inside, it's going to increase your efficiency. And most important is related to your kernel. Kernel are generally a multi-threaded. Okay? Kernels are generally a multi-threaded. After this, you're going to find out a lot of kernel in this slide module 4. Multi-action executing simultaneously three things. First is heavy word process. This one is the old version, which is a traditional process. Last time we didn't use this anymore. When we have tried to open a multi-action, we try to open words, we try to open Excel, we want to open our Photoshop, we have a multiple, but might be also, although we just try to open one, might be it's a heavy program, like After Effect, let's say After Effect is quite heavy, so there are too many process that you need to do, so it is heavyweight process. But normally last time we didn't have a treat, that's why we need to do it one by one, we cannot do it simultaneously, so it is known as heavyweight process. On the resources and passive element, that is the most important and easy for you to differentiate between passive element and active element. Might be you can be asked also, you were given with the details on the resources passive element, what is this? So you need to know, oh, this is the statement for a heavyweight process. While for the light process, our treat now, which is, you know that is related to your CPU and it's going to have a schedules for execution. So you're going to have several treat in only to open one program, execute and doing the process. And it is active element compared to the heavy process, either passive element. While this one, last time you have only one by one. And when you are having a multi-threaded application program, which is currently we are using a multi-threaded, it contains several threads running at one time only. Same or different priority, it's depend on your process, of course. Example, when you try to open your web browser, your Google Chrome, and you have a several tab inside, there is a lot of process you need in just opening your web browser, and also time sharing system. Okay, here is the definitions, differentiation between thread and also process. Last time in module 3, you look into process and program. Isn't it? Process and program. Now you look into thread and also process. Here is item share all thread in process. This is repetition from previously. So you can see item share by all thread in process and item private to each thread. So here, for per process item and per thread item, what is listed for process item? So this is the per process item, and here is the treat item. So you need to remember all the item available inside. Okay, here is an example between single and multi-threaded process. Okay, imagine we want to open our Excel. We want to open our Excel similar program. When we want to execute same program, it's going to run a same process. But in one process, if we are using our single-threaded process, we're going to have only one thread in one time. One thread in one time. Let's say at 0.02 millisecond, we have one thread. After that, we finish on the thread. Might be this thread are looking at checking your network. After that is finished, it's go to 003 millisecond. It's try to open and check your data recovery or data. It might be next 00006. It's going to check your grammar or checking your wording and so on. So there will be a one by one process. But you can see on top of it, it's going to share a similar things at your beginning of your module, pages 1. This is the things that you're going to share. Okay. Code data file, this one is share. And in a single thread, you have a register and stack, but it's only one register and one stack. While if you are having a multi-thread, this one is similar because you are going to share similar things. Although you are having 1, 2, 3, you share similar. That's why you're going to see it's sharing. It's not dividing. Okay, it's sharing all these items. After that, you're going to divide into thread. This is thread 1, thread 2, thread 3. Then every thread you're going to have their own register and stack. Register and stack, register and stack. Okay. So if you are having another thread, you have another thread that you need going to have a register, stack, register, stack, register, stack. It depends on your process. What is required for you to do the process. So this is a multi-thread process. It's quite similar. Everything is basically similar, only is having a multiple. You just need to make this to be compact as one. This is this one. You duplicate, you have another one. You duplicate, you have another one. And on the top of it, at your pages 1, in the beginning of this thread module 4, you're going to share these items together. Okay. Related to a server architecture, when you are having a multi-threaded, what is basically happen? So you as a user, or we call as a client, normally when we are dealing with a server, okay, when we are dealing with a server, we're going to try to send a request. Last time, I think module 3, I forgot already. It's related to function call, system call. Actually, your system call, you send a request. You try to like double click www.google.com. What happened is you try to go to this server, you try to go to this link. This link, they are having at the background, okay, they are having their own server to handle this thing. So you're going to ask, I want to open this, can or not? So you ask them. Ask is request. You ask a request, can I open this web link? So where you going to request? You're going to request to their server actually. So when you try to request the server, because you are going to have the multi-threaded example for a server architecture, there is a lot of other requests. Might be you just want to use our UTM Wi-Fi. Okay, UTM Wi-Fi, we have a server at our CICT, CICT UTM. We have server to handle every single thing in our network. Okay, this is server. It's going to be like divided into school of computing. Actually, in above there is a lot others things, okay, architecture before you go to the server, but later on you're going to separate to school of computing, and then SKE, mechanical, college. The college, there is several college, so it's everything is handled by server. Okay, if server need to be upgraded and etc., there will be like UTM will send you an email, okay, we're going to have a server down and so on. So for this server for this server, if you try, okay, before you can connect to your, let's say this is our school of computing, you are here at lab N28, let's say N28A, you just try to connect your mobile phone with the internet. We call as UTM Wi-Fi. For UTM Wi-Fi, if we want to connect to the Wi-Fi, you just directly connect it. But actually, you try to connect to the server, and server will reply for you to fill in with the information, username and password. This is actually what is written. And if you already fill in, you send it back to the server and to request, okay, this information, this is authentication of me, so can I connect to your network or not? So you send a request to a server. So this is what is happening here. Okay, you try to send a request to the server, and then what will server do? Sometimes it's directly go and give your output, but of course it's going to do a process. So when it's receive and okay accept, so it's going to do some activity, some process. So each process going to open a tree. Let's say there is several tree, so it's quite similar to your computer architecture. When you have input, you have output. So you have a process. Who process this? Your CPU. Similar also, if we are related to our server things, a server will process and directly give the output. But sometimes it also having a looping for you to have something that is stored. Might be you need something before you can proceed to output. Similar also on your server. Sometimes you need to have that, like maybe you need to wait for a while. Your information is not enough, might be. So instead of directly open a process which is strict, you need to ask your user or client to give another addition information. So, or might be you need to wait for a client to provide you with addition requests, or just awaiting to listen from your user. That's why you have a looping there. And if everything is enough, your password, your username is already given, so server will create a new thread to service on your request. That is what is happening here on the multi-threaded server architecture. And okay, in terms of application, this one is a normal and day-to-day applications that you are using. So used by many software packages that run on your desktop PC. Let's say your words processor. Okay, what is your word processor are doing? They're going to have a thread for displaying a graphic, because you're going to have things like this. This is a graphic. Last time we learned on GUI, isn't it? GUI things that you can see. It is like images. So it is a graphic. You need to have this thread. Another thread is reading your keystroke. Maybe you are having it's depend on what is your Microsoft that you available. Sometimes checking your grammar, sometimes checking your space and etc. That's why sometimes when you didn't have a space in between, or too many space, you have like a red line there. So it is all in there, depend on the program that you are available. But this is example what thread that available in your application. Another example, which is your web browser application, Google, Firefox, Safari. So one of the thread display image and text, which is similar to your graphics. Another thread which is retrieve the data from a network. This one is needed when you are connecting to the browser. But your word processor also, as I mentioned, it's depend on your application, okay? Some words is just your notepad. It also some sort of word processor. Notepad sometimes, I don't know, might be I can't see it's connected to any network. But when I try to open my Microsoft Word, especially I'm using 360, it needed for me to connect to the network. So it is need to retrieve data also. So it's depend on your application, but this is just example, okay, what is happening. And for web server, related to web server application, when you are having a web server like Apache, what else example of web server? So you are having a thread that will create a service that requests your server application. So it's going to similar to this, create a new thread to serve the request thread. I don't know what else that web server having, because normally we are not applying our web server. I forgot. I think if datacom subject, you will try to learn on web server, because you need to be a web or server programmer, like depending on Apache. There is a lot of other tools and application that you can use related to server application. Okay, so this is example. You can have a several thread in one application. Okay, what is the benefits on having the thread? First is to having a responsiveness may allow continuous executions if part of the process is blocked. Example important for user interface. So you can have a responsiveness. Second, it's good for you to have the resource sharing. So thread are share your resource of process. This one you already learned previously several times. Easier than share your memory or message passing. And it is economy, which is cheaper than a process creation. Thread switching lower overhead than text switching. And lastly, scalability, which is take advantage of multi-processor architecture because you can have a multiple thread in one time. So this is all the benefits that you can get when you are applying the thread. And of course, it's a multi-threaded. Okay, any question on your threads? This is just the overview of thread. Now let's take a look into our multi-core programming. So on multi-core programming, we have several examples in the differentiate between multi-core system or multi-CPU system. If you are having a multi-CPU system, how it's going to be like? If I imagine it might be, I can have, this is my CPU. Maybe I have another CPU. I don't know. If okay, I mentioned if this is my first time I heard about this multi CPU system. Okay, normally multi CPU system are having a multi CPU. Of course, you can see have a multi CPU, but it's going to be placed in a computer to provide more computing performance. It's normally in require for you to use in like super powerful process for the server to handle many networks in one architecture. So you need to have a multi CPU system. While multi-core system, although our single laptop, currently we are having a multi-core system because a core is inside our CPU. Multi-computing core are placed on a single processing chip. So in one single processing, this one you already look into your COA subject. Although in our beginning of our OS subject also, we already look into in a single chip, we can have a multi-core system. Multi-core to appear as a separate CPU on the operating system. We have only one OS, but we have several core inside. Okay. And in on a multi-threaded programming, it's provide a mechanism for more efficient use to multiple programming core and improve the concurrency. You can see here, this is all the multi-thread programming. So you can consider an application with your 4 threads Example, if you are having 4 thread, what application will be doing. On a system with a single computer core, you have only single computer, only a one core there. Concurrency means that executions of threads, okay, you are having a threads, many threads will be interleaving over time. So only one, you're going to have several threads inside. How will be happen? So it's going to concurrently execute all the thread, and it's going to be interleaving over a time. And but this one is only one single core. If you have a multi-core, however, your current concurrence means that thread can run parallelly. You're going to run this similar also at 0.01 millisecond. You can run another thread. You can run another thread. You can run another thread, because the system can assign separate thread in each core. This one, thread 1, this is handle thread 2, this is handle thread 3, this is handle thread 4. So in 0.01 millisecond time, if you stamp at this specific time, you can have several threads. While if only one, you need to wait and finish, and you do another thread and another thread. Although you are having a multi-threaded process, because you need to have several threads to run one application. Okay, there is a fine but clear distinctions between concurrency and parallelism. Later on, you're going to go deeper on parallelism. Okay, a concurrent system support more than one task by allow all the tasks to make progress. While for your parallel, it can perform more than one task simultaneously. So that is different between concurrency and also parallelism. That's why it's possible to have concurrency without a parallelism. That is the thing that you need to know. Here you're going to look deeper on parallelism. Okay, although you can see here only two type of parallelism in here. Later on, in your year 3, I guess you're going to have and take HPC subject. If you take HPC, there is a lot of other type of parallelism in your one single computer. Here in your OS subject, we only look into two types, which is data parallelism and task parallelism. On data parallelism, it's going to distribute subset of data, although it is a same data across multiple core, same operations on each. So let's say because you are sharing your data just now, like, so you can have several core 1, core 2, core 3. As example, you're going to have same operations. Maybe you are trying to open Microsoft Excel, so same operation process, but in here you're going to distribute your subset on the same data across a several core. While for the task parallelism, you're going to distribute the threads across the core. Each thread perform unique operation. So each thread just now is going to similar to here. You're going to Alhamdulillah, to perform a unique operation. As number of threads grows, you're going to have several, right? Many. So architecturally support the threading. How you going to support The CPU have core as well as hardware threads. It's considered Oracle Spark T4 with 8 cores and 8 hardware threads per core. So this is the requirement for you to support the trading. Okay. Before we proceed with our next multi-core and multiprocessor, we stop under parallelism. We will have a short break, 5 minutes. Later on, we're going to continue. I need to call others of your friends just now. They are here, but suddenly they gone already. Okay. So let's take 5 minute break. Okay, let's we continue back our module 4. Okay, just now we already look into treat on parallelism, and now we're going to look into the multi-core and multi-processing system. So there, multi-core and multi-processor system are placing pressure on programmers. What are challenges that programmer need to face when they are trying to do a multi-core or might be a multi-processor? First is to divide the activities. Divide the activities in a program that you are doing. Try to balance what process that can be divided. Data splitting, you need to differentiate between some data depending on the functions, data dependency, and also testing and debugging. So this is several example on what are facing by programmer in terms of trying to placing a system called as a multi-core or multiprocessor. So parallelism imply a system can perform more than one task simultaneously. This one is just a repetition. While concurrency support more than one task, making progress. Example of single processor or core scheduling process providing concurrency. So this one is just a repetition from several slide before this. So let's take a look what is the definition in terms of graphic view. So in terms of diagram, we can see this example for concurrency and this is for parallelism. And concurrency normally is going to be executed on a single system, single core system. So when you have a single core, you can see on time, okay? On time, you can have like task 1 or treat 1. And then after finish, then you are doing a treat 2. After finish, you are doing a treat 3, 4, and then it's going to continue, let's say, for the treat, moving on time in a single core for concurrent execution. While for parallelism, you can have several core. You can see, you can have core 1 and core 2 at the time. Okay, let's say over here at the time 0.1 millisecond. Okay, box 1 or 0.1 millisecond. For concurrent execution, it's just running for thread 1, while for the parallelism, you're going to run thread 1 and thread 2. And 0.2 millisecond, thread 2, while for parallelism, it's run thread 3 and thread 4. 0.3, it's run thread 3. But for parallelism, it's run thread 1 and thread 2 back because it's going to be looping continuous until finish to execute something. So in the overview of graphic and also like a diagram, so last time we look into sentences. Here is something that easier for you to understand. Okay, differentiation between concurrency and parallelism. And what else you need to know about concurrency, and what you need to know also about the parallelism. But parallelism we're not going to touch deeper anymore. Okay, in concurrency, it is in uniprocessor multi-program system. Uniprocessor because you are just using a one single core. Okay, and executions of processes or a thread are interleaving in the time to yield the appearance of simultaneously execution, which is similar to this statement. Similar to this statement. A single core concurrently execute the thread while we interleave over a time. So repetition, you can see here. Mana dia? Statement, okay? And it also known as a concurrent processes or a thread execution. So you need to know that it is actually a parallel processing, does not occur on the concurrency. Uniprocessor system interleaving is going to be, you can see the executions. Let's say you are opening process 1. Process 1, you're going to have thread 1, thread 2, thread 3, and so on. But it's going to do task 1, let's say, thread 1. After thread 1 finish, for the process 1, might be process 1 trying to fetch the data. This one is connect to server. This one checking error, let's say. So this is all a process that are happening. So thread 1 is going to run here. After finish, then it's going to execute to do server process, which is thread 2. And then after that, it's going to checking the error and so on. After finish, might be it's going go to directly to here, or might be it's go to here. It's depend on how process are dealing with the applications that you execute. This example you're going to see is go back to the thread 2 and then thread 3 backs and then thread 1. It's depend, okay? So you can see here, this is following the sequence. But sometimes you can have jump to another thread. It depends on your application. Might be after it's need for you to checking error, but there is a need for you to go back to the server. Might be after checking the error, might be you need to try to check and fetch the data. In terms of multiprocessor system, it's going to have the overlapping because you can have several threads in one time, isn't it? So overlapping and interleaving of processes, example, execute, and parallel processing sometimes occur. So you can see sometimes at one time you can have two threads together. Sometimes you can even have like this. Okay, you're going to have the overlapping and parallel processing. Sometimes it's occur parallel. No, might be here you can put something that happens here. So it can have the parallel together, P4. And in terms of concurrency, we can see in terms of 3 different contexts. First is multiple application. You open multiple application in one time, although it is just one system call, right, for concurrency. And then structure application or operating system structure. First, in terms of multiple application, you can have a multiple programming was intended to allow processing time to be dynamically shared among several active applications. So you can have several apps that open Excel, Words, Photoshop, and you are sharing the data using a multiple programming. And on the structure application, application can be a set of concurrent processes. And lastly, operating system structure. Processing system is a set of processes or a tree. Example that you can have on the operating structure, which is Solaris and also Linux, which is Microsoft.no concurrency. Interleaving and also overlapping execution of process can be viewed as example of concurrent processing. So this one will be more deeper explained in our module 6. But both of it represent the same problem, just as sharing a global resources. So how is it? A global variable is one of the example. Second, when you are trying to share a file or a database. And another one, managing the allocations of resources optimally, such as the request use of the particular input-output device may lead to the deadlock. So deadlock, deadlock, we find this in, forgot, module 2 module 2 or module 3, right? Last time one of your friend asking about deadlock, isn't it? Another example of concurrency. Another example of concurrency, two or more threads need access to share resources that must be used by only one thread at one time. Sometimes let's say you have thread 1, thread 2, thread 3. Maybe you have thread 3 at one time when you try to run, but you need to access, you have 3, right? Data, what else that you are sharing together. Might be at one time they are trying to fetch the same information, which is share resources last time, at the page 1. There is 3 things that we share together, but might be at 0.02 millisecond. Both of the threads are trying to fetch the same resources. So this is a thing that can be a concurrency. So when a thread is writing to a file, a second thread must be prevented from writing to the file at the same time, because you cannot try to fetch simultaneously when you are having a concurrency. In terms of programming, concurrent processing system, example of if you have a job that use several processor, we call as a multiprocessor. Execute set of instruction in parallel, require programming language and computer system support. Okay, here is example when you try to invoke this equation. So this is application of concurrent program. Might be you have several, right? You have several things that you need to do, but you need to do it one by one. So you have a step 1. What you need to do, you're going to do this and this first. So step 1, store the different in T1. So you are putting it in thread 1. And treat 2, you are going to store the total of sum D plus E. Step 3, after you done this, you're going to multiply your treat 1 and treat 2 together. And then you're going to store, oh, this one is the power of total 2B. You're going to store back to another T1. And following the sequence. So all of these are uniprocessor, which is sequential computations. So that is a concurrent programming. When you are trying to do a programming, concurrent programming means that you are doing a sequential things. You need to do one by one in one time. You cannot do directly all and get one answer directly at step 1. So this is called as a application of concurrent programming. So this is example. So similar also this one, we have a operation. So all of this is a example of your concurrent programming. So there is also another example in terms of when you try to open your task manager. Kenapa I tak boleh buka I punya task manager? Okay, let's say we try to open our task manager. We can see a lot of application, background process also having in one time. You can see. So this is example in your slide in terms of your OS version. So here is what is process that available in one time. You can see a lot of applications similar to mine currently, but active is only 4. But the rest is also having in background. What is this? I just found this one. Alibaba. PC. I don't have this. What it's having here? So there is a lot of others activities you can see here. I don't even sometimes realize that all of this in my background or my application process. This is all the process that are currently doing. So it's, you can see it's taking my memory also, how much memories that are taking from all this application. And for this example, you can see what is the user. For us currently, we have also users system. what we can do for our current user. And in terms of performance also, you can see in a graphic, basically is also similar like this, but we can see it in terms the GUI. And a lot of other you can try to explore. Last time in our beginning class also, I already shows you in the task manager. So that is example on our concurrent process. But currently we are using a multi-threaded process for our computer. So any question related to your treat? So mostly it's all on theory. I don't think that you can cover yet until module 5. Later on, it's going to be interesting when you are doing something in a technical way, right? But all of this, before you can go deeper, try to play around with your Linux. You need to understand what is basically all the theory related to all functions that available. Okay, if there is no question, we can stop our class, and might be please make sure that you submit the lab 1 on time, okay? Might be you have another more time here, you can complete. Just now might be some of you didn't aware related to your related to your screenshot things for part A and part B. Please try to do it by yourself, okay? You screenshot and then submit directly. For those who already submit, it's okay, right? So it's easier for you to focus for test 1, okay? Thank you, class. Meet you again on Wednesday, right? Okay, bye-bye.
Thank you, Radhe.